Hello children, in this lecture we will discuss paragraph number 11.6, page number 11.19 and the heading is important compounds of carbon and silicon, group 14 elements. So today we will discuss compounds of carbon and silicon, and the first compound is carbon monoxide. So as you can see here, the molecular formula of carbon monoxide is CO. Preparation, and the preparation method according to your reduced syllabus, the first one is only first point by direct oxidation of carbon in limited supply of oxygen or air. Direct oxidation of carbon in a limited supply of oxygen or air. So carbon with oxygen on heating forming carbon monoxide gas. Okay, so in a limited supply of oxygen, oxidation of carbon is taking place partially, and due to the partial oxidation of carbon, carbon monoxide is formed. Okay, and third preparation, it is a very important preparation, that is why we are going to study this preparation also. So on commercial scale, it is prepared by the passage of steam over hot coke. Coke, carbon or coke. Okay, so carbon or coke. So when vaporized water vapor or steam is passed over the coke at around 473 to 1273 Kelvin, mixture of carbon monoxide and hydrogen is formed, which is known as water gas or synthesis gas. Okay, so this mixture is formed, which is known as water gas or synthesis gas. This mixture is having equal amount of these two gases present together, means 50-50% of both the gases are present in the form of water gas. Okay, students. The next is what is the drawback or hazard of the carbon monoxide for the living being or especially for the human being. Okay, so according to the drawback of this gas, it is a very poisonous gas, and because carbon monoxide combines with hemoglobin and forms carboxyhemoglobin. So compound of carbon monoxide with hemoglobin is known as carboxyhemoglobin, which is 300 times more stable than the oxyhemoglobin complex. What is oxyhemoglobin complex? Complex of hemoglobin with oxygen. Okay, so what is the function of hemoglobin in our body? The function of hemoglobin to carry oxygen in different parts of the body in the form of oxyhemoglobin complex. But carbon monoxide is 300 times more stable in the form of carboxyhemoglobin than the oxyhemoglobin complex, and that is why this prevents hemoglobin from carrying O2 round the body and ultimate resulting in death due to the deficiency of oxygen in the body. Okay, students. Then chemical properties. and one property is there, and it's very common and most important property of carbon monoxide. And according to this property, carbon monoxide is a very good reducing agent. So due to its good reducing character, we use this gas for the reduction of different metallic oxide, especially in the extraction of many metals from their oxide ores. Okay, so very common and very important and also very useful property of this reducing nature of carbon monoxide. So it's due to its reducing nature, we use this carbon monoxide for the reduction of the different metallic oxide to obtain metals. Okay, so as you can see here, zinc oxide with carbon monoxide can be reduced in the form of zinc, and carbon monoxide itself oxidized in the form of CO2, carbon dioxide. Same way, copper oxide with carbon monoxide reduced in the form of copper, and carbon monoxide, which is a reducing agent, get converted in the form of CO2 after oxidation. And so many examples are given here also. Okay, so this is the use of carbon monoxide. So just one use there in your syllabus this time. Okay, next compound we will discuss, and that is of carbon only, and that compound is carbon dioxide. The formula of carbon dioxide is CO2. CO2. Okay, and the first is preparation. So we can prepare carbon dioxide by the combustion of carbon or coke with excess amount of air or oxygen. Okay, so when carbon is combusted in the presence of excess air or oxygen, CO2 is formed under complete oxidation condition. So carbon is completely oxidized in the form of CO2. The next is laboratory preparation. In lab, we can prepare carbon dioxide with the help of any carbonate salt. Any carbonate salt with dilute acid. Okay, so one reaction is given here also in lab. Calcium carbonate can be reacted with dilute HCl to get CO2 gas, and calcium chloride and water, these two compounds are formed as a byproduct. Okay, students, then reaction of CO2 with alkalis. So alkalis, third point, this reaction is only in your syllabus for CO2, reaction with alkalis. So CO2 is an acidic gas, acidic in nature, and it reacts with alkalis. So when CO2 is passed over lime water, what happens? Lime water turns milky due to the formation of insoluble calcium carbonate. Okay, so when we pass CO2 gas through lime water turns milky due to the formation of insoluble calcium carbonate. But when excess of CO2 is passed through milky lime water, then it again turns colorless. Milkiness of lime water disappears. Okay, and it is due to the formation of calcium bicarbonate. So on excess passing of CO2 in lime water, the milkiness of lime water disappears due to the formation of calcium bicarbonate, which is a soluble salt. Okay, so with the help of this test, we can prove the presence of CO2 gas, and also we can prove the presence of carbonate radical in the given metallic salt. Okay, CO3 2 minus carbonate radical in the given metallic salt. So in this way we can test both CO2 gas and also the presence of carbonate acidic radical. Okay, so the next compound. Before next compound, we have to discuss some uses of CO2 gas and some common uses of CO2. First, in the preparation of aerated soft drinks. Okay, so in soft drinks, CO2 is dissolved under pressure. Then second point, as a fire extinguisher. Then in the form of dry ice, it is used as refrigerant. Okay, then a mixture of 5 to 10% CO2 with oxygen is used for artificial respiration under the name of carbogen. So this carbogen is used for the purpose of artificial respiration, which is a mixture of carbon dioxide and oxygen. Okay, students, so you can learn around 4 common uses of CO2 from here. The next compound is silicon carbide. So the formula of silicon carbide is SiC, which is also known as carborundum. First heading, preparation. So silicon carbide is prepared with the help of silica. So when silica, coke, sawdust and salt are heated together in an electric furnace at 2000 to 2500 degrees Celsius, silicon carbide is obtained. Okay, so SiO2 plus 3C, SiC plus 2CO. This is the formation reaction of silicon carbide. Now some important points are given below here. What is the function of salt which is present here in the preparation of silicon carbide? The salt facilitates the fusion of the mixture. Okay, so fusion of the mixture is enhanced by the salt. Sawdust makes the mass porous. Function of sawdust is to make the mass porous, which helps carbon monoxide to escape out this from silicon carbide. This is known as, the process is known as Achenson's process. The diagram or furnace is given here for the Achenson's process. This is the preparation of silicon carbide. Okay, then uses of silicon carbide. Silicon carbide is used as an abrasive for cutting and grinding glasses, for lining of furnace, as rods in resistant heaters, for making crucibles for melting metals. So very common use of silicon carbide. Okay, due to its high melting point, we used silicon carbide for the preparation of crucibles, and these crucibles are further used for the melting of metals. Okay, the next compound in your syllabus this time are known as silicones. So silicones are the organosilicon synthetic polymers. Okay, students. So organo means silicones must having R part, alkyl part, because organo term is given here. So organo for the R, alkyl group, silicon for silicon, and synthetic polymer. Okay, so these silicones are the polymers, first thing, which are having organo part in the form of alkyl group, and silica Si, okay, and these are made up of, silicones are made up of in the form of repeated units of R2SiO, and this structure is showing resemblance with ketones general formula R2CO. Okay, and due to the resemblance of these two, these compounds of silicons are known as silicones, after the name of ketones, silicones. Okay, students, so how silicones are formed? How silicones are formed? So first we form, for the formation of silicones, first we form silanes. What we form? We form silanes. Okay, and silanes converted in the form of silanols. Okay, and these silanols converted in the form of silicones. So these are the steps through which we form silicones. First we prepare silanes, then silanols, and then silicones. Okay, so how we prepare silanes? Silanes are prepared when alkyl halides like alkyl chloride, any alkyl chloride, here you can see alkyl chlorides are reacted with silicon. So alkyl chloride, silicon are forming silane. So here dimethyl dichlorosilane is formed first. So formation of silane, then this silane is hydrolyzed, and when silanes are hydrolyzed, we change these silanes in the form of silanols. Okay, so this silanol is formed with the help of silane. So what is the name of this silane? It is dimethyl dichlorosilane, and after hydrolysis it converted in the form of dimethyl silane diol due to the presence of 2 hydroxy and 2 methyl group. So dimethyl silane diol. Okay, and now this dimethyl silane diol condense together. So number of units of dimethyl silane diol condense together by a removal of molecule of water. So we get a chain of repeated units, and this repeated chain of the units is a form of polymer which is known as silicones. Okay, so in this way silicones are formed. So these two units are joining together. Here dimer is formed, and when number of such units join together, a polymer is formed which is known as silicone. Okay, students, so this is the preparation steps or general method of the preparation of silicone. So first formation of silanes, then next is silanols, and last silicones. Okay, so this is the preparation way of silicones. Then very important point is given this side. When alkyl trichlorosilanes are hydrolyzed. Trichlorosilanes, then cross-linked silicones are formed. So dichlorosilanes are forming simple silicones or straight chain silicones. But when we hydrolyze trichlorosilanes, then after polymerization, cross-linked silicones are obtained, or we can form trichlorosilicones. Okay, cross-linked silicone may be represented by the general formula. This is the general formula for cross-linked silicones. Okay, students. So only general method of the preparation for silicone and its uses are there in your syllabus this time. So after this we are going to discuss uses of silicones. So few common use you can learn. First point, silicones being surrounded by non-polar alkyl groups are water repelling. They have high thermal stability, high dielectric strength. Fourth point, being biocompatible, they are used in surgical and cosmetic implants. Silicones are used in high temperature oil bath, high vacuum pumps. Being water repellent and are good insulators. Okay, so these are mixed in paints to make them resistant to light, damp, high temperature as anti-foaming agents in cosmetics. Okay, so these are the uses of silicones. Okay, students. So now this P block elements chapter is over. From this chapter we have discussed only the points which are given in your further reduced syllabus. Okay, students. So you are going also to prepare for your examination only those points which we have discussed in this video lecture. Thank you.